Good evening, everyone. It's my pleasure to introduce Mr. Rajesh a Senior Technical Manager at Technical Supplies International, MUSCAT, Oman, with an MTech in Structural Engineering from Wales Institute of Technology. He specializes in structural design, modular support system, and seismic design. With extensive experience handling multinational brands like Linkway, Problem, FSI, and he played a key role in support systems, anchor fixing, and passive fire protection for critical infrastructure in healthcare, aviation, and commercial sectors. Without further ado, please welcome Mr. Rajesh Salapaneni. Uh, we are very thankful that he has joined this session. Thank you, Rajesh. Thank you for joining this session. Over to you.
Hi, good evening, all of you. Hope all of you doing well. Can you hear my voice? Is it clear? Can somebody confirm on chat box?
Loud and clear, Rajesh.
Yes, sir. Clear voice, sir.
Great. Also, I would like to just request one more time. Can you see some slides on my screen? Hello?
Actually, we are just seeing the screen share, Rajesh, but it's all blank here.
It is loading, sir. It is loading.
Okay.
Loading.
You will be given, yes, Mr. Rajesh, you will be given as the presenter access now.
Okay, can you please?
Yes, yeah, now you can share the screen.
Yeah. I think I already shared the screen. Just reconfirm one. Yeah. Can you see my screen?
No, sir. It is loading, sir.
Just bear with me for a couple of minutes. There is something wrong. Is it clear now? Can somebody confirm?
No, sir. It is all still loading, sir.
Sorry for the trouble. I think there is some internet issue. Let me try from the other.
Yes, Mr. Rajesh, we can see your screen now.
Hello. Can you hear me as well?
Yes, Mr. Rajesh, we can hear you.
Great. Really sorry for the inconvenience, I think due to some network issue. So, good evening, all of you again. So coming to the topic, advanced engineering and design principles of modern building facade. So we will be more discussing about the basic design principles and what is a facade and how a facade plays a key role in a structure, or it can be a building or a mall. So some basics of engineering topics, such as like what are the different loads that we need to consider, or what are the different codes, and how do we execute it on site, and how does the end output looks. So in this presentation, I would like to also bring a case study out of my experience, which we have recently worked out. So which will be more, not more theoretical, but it will be a practical session as well. So coming to this presentation, I think we are already late by a few minutes. So this webinar will be 5 minutes of discussion with all of you, and there will be a questions and answer session for 30 minutes. And at the last, you will have a polls and feedback session for 15 minutes. So where you can poll and give your feedback. So a better option is to use Google Chrome or Firefox, and please do not do any parallel downloads, so which may obstruct, the lagging will be there, or the voice or video might not be clear. And since we have more number of audience, so I request all of you to put your questions to the end of the session, where we have a dedicated time for the question and answers. So before going to the presentation, a short introduction about myself. I am Rajesh. Currently, I'm working as a senior technical manager in Oman. And by profession, I'm a structural engineer. I'm specialized in steel structures, mostly pre-engineered buildings and hot rolled. Also, I have an additional experience or a qualification which related to the anchoring system, which we call it post-installed anchors. Either it can be a chemical, mechanical, or nylon anchors. Also, I deal with a little bit of passive fire protection system, which is a quite advanced topic that comes in the construction nowadays, that we see a lot of fire accidents in the malls and buildings. So this is also a new topic which I have recently taken up. So coming to the contents, today we'll be discussing about introduction to facade. So the basics of facade, what is facade and what is the role of an engineer, and how far the engineer's responsibility or the engineer's role is involved in designing a facade or executing a facade. So coming to the types of facades, there are different types of facades which will be chosen by the client or contractor, or according to the requirements of the project. So since our time is limited and this is only a first session, so we might be limited talking about the ventilated facades, and specifically for the stone cladding, which I will be explaining further more in the upcoming slides. And coming to the third one, the structural engineering considerations. So what does a structural engineer does it? So where I will be taking a live example or a practical example of from the scratch, from the zero, how does the facade is designed and how does the facade is going to get executed on a building or a structure. A case study will be presented in this, so which involves the basic facade design, which again comes up with wind loads, seismic loads, and temperature loads, where most of you already is teaching to the students, and you might be practicing in the industry about all these aspects. And also the anchoring system and connections. So, which is again, when we choose multiple materials, either it can be a stone or a glass, or it can be any composite panel or precast panel. So how does this is getting fixed to a building? So there will be a mechanism which is called anchor system. So we will see that. And last but not the least, the question and answer session. So coming to our first topic of introductions to facade. Can somebody tell me what is a facade and why a facade is required for a building, and what is the significance of facade? Is it really required for a building to have a facade? Yeah, can someone answer? What is a facade and where we come across the requirements of facade in either theory or yeah. Well, let's move forward. So facade is nothing but a skin, as simple as we all wear shirt and to protect our skin or to protect our core body from a lot of external. Either it can be a winter season or cold season. To protect our body, we wear certain type of clothes. So likewise, a building is also needs certain protection against. Either it can be a harsh wind or extreme climates like cold winter where you have multiple seasons. And also, as we dress up to look good to the people or to the society, the same way when you construct a building or when you construct a structure, so always we anticipate that the building or the structure should look beautiful or iconic. So facades is the one who defines, who brings up that value to a building by showcasing the architecture. And also environmental performance. So how does this environmental performance is going to be achieved or are going to be incorporated into a building? So let's take a practical example that you might have heard or we might have come across certain terms called green buildings or energy efficient or energy saving buildings or LEED certification. So these are the terms that we come across in the subjects. So yes, coming to the practicality, these are all a part of facade. Facade is the one who is going to contribute more of its value. So what does a facade does is you can see on the screen where my cursor will be pointing out. Just a second. So this is the interior side of the building, and this is the exterior side of the building, where you will see a different situations the building prone to, like it can be a direct sunlight, or it can be attack of UV radiation, or it can be an attack of cold weathers. So from these cold weathers, the building is protected. So how does the building is protected is that, as I mentioned in the previous slide, or the ventilated facade. So there will be a gap between, say, assuming that this is your either a stone or a precast panel, or it can be anything, even a glass. So a glass will be installed at a certain distance from your building outer periphery. Sorry, building outer periphery. So this gap is what you see on the screen. So usually maintained maybe a 10 centimeter to 20 centimeter. So what does it creates is it creates a low pressure between your building and the facade panel what is provided. So what happens is that, say, you see there are certain gaps over here where you would see some drain points or where the air inside a building. So these are very minute gaps of 5 to 6 millimeter, which will be maintained across the building between multiple panels. So when the air comes up, say, we see generally the wind travels at a speed of 150 to 160 kilometers per hour. This is the usual wind speed that we design a building or a structure, a normal one which I'm talking about. So when the wind comes at that extreme speed, so what does this facade does is it controls the wind and it allows a limited wind to go travel inside this cavity or this gap, which we call it. So since the force of the wind is arrested or eliminated in such a way that only a minimum amount of air pressure or the air is allowed to go inside the facade, so which creates a low pressure. So there will be a pressure difference. So as we all know, the principle of pressure difference, what happens is when you have low pressure, so what we call is it's going to rain today. So in the other sense, it means that so the area is going to get cooler. So which will directly impact on your building that the outside temperature is going to be much higher, maybe 20 to 30 degrees centigrade or even more. But inside temperature will be always maintained at a room temperature of 25 to 27 degrees centigrade. So this is the major advantage of having a facade, specifically a ventilated facade. So the effect, whatever I have explained, the pressure differences between the exterior and the interior of the building is called a chimney effect, or we call in practical terms as low pressure zones. So by creating a low pressure zone, you control the heat that is transmitted into the building. So which in other terms, what we discuss is the green building parameters or energy efficient buildings is nothing but you have to control the heat, you have to use less power in the building. So you should not depend on external sources of power like electricity or solar or whatever. So controlling them, Facade plays a key role by achieving certain certifications or certain what you call it, red points to achieve a lead certification or this. So this is the overview of a basics of facade. So what is an engineer role in a facade? So as we all see in our subjects, we will be more discussing about different types of beams or different types of solving shear force and bending moment diagram. So, and also we will be discussing about the design of a beam, design of a column, but very a few cases that we come across and discuss that how to install a facade panel onto a building or how to install a marble onto a wall. In common. So such topics or such parameters are also involved a major engineering and major amount of contribution is required from structural engineers especially. So this is also a topic we will be discussing, and as you all know, every material and every what you call it, every material has its own thermal coefficient values. So when it is subjected to exposed to sun or exposed to some heat, it has its own expansion and contraction properties. I mean, like the concrete behaves in a different way, and the steel behaves much harsh or much prone to when it's prone to heat. So the expansion is much more than compared to other materials. So how do we deal this, and how do we incorporate all these into your building? So this is what we are going to discuss in this further slides. Yeah, coming to the ventilated facade, here is a quick glance. There are three different types of facades, which is double skin facade, where you need to have a lot of, it's again the amount of the requirement requires, like if you say it's a green building, there are certain levels of stages of that proving that is a green building requirement. So through that only these facades are selected. So the more energy efficient building you want, so the more better the facade you need to select. So on the screen, you see that a person standing inside the building, and the blue color lines, which I'm highlighting over here, are the glasses. Mostly the double skin facade comes from the glazing or glass. So there are different types, again, toughened glass and laminated glass. So the idea here is the principle is the same. There is going to be an air gap or air cavity, which is created with two glasses. So the idea is that again, when the heat or the wind comes up, so the impact is resisted by the outermost glass, which is exposed to the environment. And there will be a low pressure created by allowing some vacuum or suction inside these two panels. So which ensures that heat is not going to transmit from one material to other material since there is an air gap or air void. So this is the whole concept that is followed in different types of facades. So this is the other one which we are going to be more focused and which we will be discussing furthermore with a case study. So stone cladding. Two of the greatest examples I can give is if you see our recent parliament, which is built in India, Delhi. So the new parliament is completely done with a stone from Rajasthan. So this is a live example, which I'm also a part of, certain part of the work, but not into the site execution, but into the design phase. And another project you might have all heard, there is diamond seller in Gujarat, diamond seller, or say something was there, Gujarat diamond seller. So he also made a iconic building, which is a millions of dollar project it is. So it was also done with one of the sandstone from Rajasthan. So these are the two iconic projects where you see the lot of modern facade is coming up. So these are some of the great examples. If you get a chance to visit anytime, that is one of the best examples for the facades in recent days in India. You can experience it in live. Yeah, and coming to the third one, perforated lowered facade or a metal panel facade. So these are some of the examples from the country where I'm living. So where you will have an aluminum sheet or which is resistant against corrosion, or a stainless steel sheet, so which will be fabricated or which can be molded into a certain shape which is required by the architecture or the building requirements, and which will be installed against the structure. So these are the different types of ventilated facade that is followed across, but there will be different names in different industries and standards. But however, coming to the summary, these are the different facades that will be followed across the globe. So as I mentioned, we are going to discuss about a case study, particularly for the installation of stone cladding or stone panels. So in the industry, there are two systems or two principles which are majorly followed. So where you can see on screen, one is called a undercut system, and the other one is called, so this is called as a pin system, and this is called as an undercut system. So I'll explain you the difference also, what does it makes and what difference that it brings to the structure. So pin system is something which is fixed on the side of the panel or the thickness of the panel, where you can see the red color mark which I'm highlighting on the screen. Whereas the undercut system, which is fixed on the body of the panel. So it will be fixed on this. So what difference it makes? Either you fix it on the thickness or the edge of the panel, and what difference it makes when you fix on the body of the panel. So can someone quickly take a comment on this? That can somebody explain what difference it makes? I'll just draw you a quick sketch. So assume that it's a simply supported beam. So you have, you have a support point over here, and there is one more simply supported beam. You have support point a little inside. So this is consider one, and this you consider number two. So according to you, what is safer? A simply supported beam with end supports is safer, or a simply supported beam with, or a propped cantilever, we can say. So which is safer in this? Can you guys hear me? Hello?
Sir. Hello.
Yeah, I can hear. Please.
Sir, I consider it as overhanging.
Yeah, good. I couldn't see you since I'm presenting, but yes, that's the right answer. That's a as you all see that when you're holding something, it's simple that unsupported length. So where if you consider the length between the two supports is L, okay. So here it is going to be L, but whereas it will be like, 1/3 of the L. So where we are dividing and keeping it, and which we are making it as a cantilever on either sides, which is obviously safe in terms of your deflection or in terms of your bending stress. So whatever you call it, or flexural strength of that particular piece. So in simple, you can take a paper. If you could see me on screen, I don't know whether it is clear or not. So holding a paper, holding a piece of stone like this, or holding a piece of stone with two hands just in mid of somewhere. So what is going to be stronger is your prop cantilever or overhang option, right? So yeah, again, coming to the system, the pin system is a quite old traditional. It is in practice, it's not bad. It's a quite good system, but it has its own limitations. As we see, every material or every system has its own limitation. So it's the same. So undercut system is a advanced system or a new system, which is much safer and which gives sort of peace of mind. As you know that you are going to a mall or stadium or whatever complex, and there should not be, there is a stone which is hanging at a height of 40-50 meters height. So it should not fall. If it falls, then it's going to cost somebody's life. So we should be very cautious, and we should take that responsibility as a structural engineer to ensure that whatever solutions and whatever um, designs that we are providing are safe and which will not cost somebody's life. Yeah. So out of that only these advancements has come up, and you got the trends has changed, and different systems has come into the market. So coming to our case study, so you could see on a screen, this is one of the projects which is handled by our company and our team, and I'm a part of it. So this is a commercial and a residential building which is based in Oman. So where you see why I presented this particular project is in this project you could see almost all the ventilated facades what we discussed are presented in this. So if you see on the screen, these particular parts are with stone, where you see these strips, and there is a perforated metal facade, and there is a glass. I mean the ventilated glass or the double glazing which I mentioned. So the idea of presenting this is that there could be multiple systems which can be adopted in a project, or it can be one system, or it can be a combination of all different technologies. So which we could generally face in it's not very rare that we will not see multiple systems. It's very obvious that any building you choose, there will be a glass, at least a window or a door, or there will be a marshbi or something which should look beautiful. So we'll be discussing about the case study of a project which was designed. So just before going to discuss about sorry, let me connect my answer. Yeah. So just before going to this, what I would like to explain is this is the typical proposal or a drawings which we generally make to present it to the consultants, or sometimes we also present it to the universities to take approvals from the universities if the projects or the client specification comes up. So this is a building where you could see the floor to floor, and there is a block work. I think it's pretty clear that you can understand there is a 3D visualization. So there are certain metal profiles which are installed against the building height. So, and the gray panels, what you see is the natural marble. I could say Omani marble it is, or generally we see granite, which is also quite famous from Indian market. So these panels needs to be installed against a building which is 40 meters in height from the ground level, and which is close to sea, which is around say 15 to 20 meters away from the sea. So why I mention these points, when you have a building which is located on the beach side, so what happens is that you get abnormal wind pressures or the abnormal wind impact on the building, which is directly exposed when there is no, tall buildings or some heavy structures or mountains that, reduce the impact of wind. So that's the reason that's one choose. And coming to the fixing details, so I would be sharing this presentation also, so you can go through it further if you need any clarities on it. So I'll be moving forward a little quick. So there are certain components involved in it, like you see in detail, a call-out detail is presented over here. There is a panel and there is a concrete, and you see the white pins kind of option. This is nothing but the anchoring system, which we call it. Like it is not something which we will not see. There will be, like for example, if you bought a TV and you want to fix it to a wall, so you will use some screws and plugs, right? So since it's a TV, a weight of maybe 100 or 150 kg, so you're using a small screw. But just imagine you want to clad the whole building with stone, which tons and tons of weight. So you need something strong and rigid enough to withstand the loads. Maybe, as I mentioned, 160, 170 kilometer per hour wind. So it creates a lot of intensity on the building and the fixing and the panels, what you are selecting. So those details will be discussing. So coming to the first topic, what the different loads that comes up in a building when you design it, or when you think of a building as an engineer, what are the different types of loads that you come across? So can somebody comment that what are the different types of loads that you are usually consider when you're dealing particular aspects? It can be anything. You can keep it in the comment box also. The other side, I'm reviewing the comments. Yeah, earthquake load. Yeah, Mr. Anup said. Yeah, Miss Hima, yes, dead load and wind load. Yes, obviously. In the presentation, we discussed about one more load. Yeah, dead load, live load, wind load, earthquake load. Yes. There is one thing which we are missing, as I mentioned. This is a facade which is exposed to the environment. So each material has its own thermal coefficients. So expansion and contraction happens on its own behavior. Yes, weather conditions, which is nothing but temperature loads. So the facade makes a major difference in temperature loads. So yes, when we choose facades, as I mentioned, you could see on the previous proposal which I mentioned. So there is three different elements which are involved. So there is the concrete, which you see in the red color, and then you got some profile, which is made of steel. And then again, there is a panel, which is naturally available stone. So each one has its own thermal coefficients. The behavior of the material, the expansion and contraction, is completely independent. So steel expands in a different way. Maybe it expands more, the stone expands less, and the concrete expands in a different parameter at same temperature. So how do we accommodate this? So this is what we are going to discuss. So when we are choosing a build, or when we are going for a designing of any structure, or it can be doesn't need to be a structure, or it can be a panel, or it can be any of a building element. The first and foremost important thing is that we need to choose, or we need to identify where it is located. So there will be impact based on your building location. Either it is just quick example. There are a lot of parameters, but quickly to summarize, terrain category is one. So what is the surroundings of your building? So assume you have a building of 10-meter height, and your building is completely surrounded by tall structures, which are like 30 or 40 meters. So what happens is generally these buildings are designed for 80 to 100 years of life. I mean, still there are certain codes, either it is temporary building, or storage facilities, or hospitals, or commercial and residential buildings. Based on that, your building life is designed. So when we choose such buildings, so we need to take care of your topography. What are the different situations are across? So we have codes who defines what kind of load we need to take, and what kind of parameters that we need to consider. So a quick example is that since if I refer to Indian codes, IS 875, which defines the impact of wind, how it has to be considered, and IS 1893, if I'm not wrong, which defines your seismic impact, how the seismic impact needs to be considered. So whereas on international note, we follow American standards or British standards. So AC7 is the guide for all of these, either earthquake or seismic, which can be defined in a single code. So if anybody would like to refer, you can also refer to these codes. I think they're available with all of you. So coming to the wind design, which I have mentioned, a lot of pages which reporting and all, but however, we'll quickly go to the wind analysis. So as I mentioned, there will be a wind analysis. So this particular piece, the building height is 40 meters. So any building that comes above 18 meters is considered, above 18 meters is considered as a high rise, and below 18 meters it is considered as a low rise building. So what does this high rise and low rise effect comes in picture? So whenever you consider the height, so what happens to the wind and what happens to your seismic? So the more the height you go, the impact of wind is going to be higher. So if you see the Bayesian diagram of a tall building, there will be a minimum wind pressure on the zeroth level, and the levels keep on increasing, the wind impact will be higher. So it's a freestanding cantilever in simple. So this is the effect that considering a building as low rise and high rise predominantly affects. And as I explained that there are certain parameters that we need to consider is the exposure category. So there will be categories of A, B, C, D, which is defined again. What is surrounded, what is across your building, either it is open to terrain, or there is a closed terrain, or there is a mountains around the building. So there are different parameters, and there will be certain the directionality factor. So these are all the data which is available in the codes. Maybe the idea is that they gather the data of last 100 200 years, and out of those significant effects, or certain cyclones are also considered into parameter when they define the codes and they define the standards. So these are all incorporated, and some basic input data needs to be considered from the code, like how do we calculate the unsupported lengths or the deflection limits for simply supported or cantilever or fixed beam, which were defined in the codes. So similarly, there are certain parameters defined in the code for calculating the effect of a wind or a seismic or a thermal or dead load or live load, so which will be considered in it. So these are also the graphical representations or the pictures. So based on the building type and based on the building geometry, either it's a circular building or it's a rectangular building, the shape of the building also makes a predominant effect on the pressure of the impact of the wind pressure on the building. So considering all this, we will be arriving to a wind pressure called, so where we generally hear about the speed of the wind is 45 meter per second or 160 kilometer per hour. But however, when it comes to the design, or when it comes to the designing of any of the elements of a structure, so it will be always converted into pressure. So there are certain formulas and certain coefficients that we need to be considered, which I will not be going in detail. So just to give a quick overview. So once the building design has to be initiated, so first you should be clear about the parameters, and you arrive in your wind speed. So once your requirements, what are the requirements for a building, what is the impact of wind, and what is the impact of the the seismic. So it is nothing but the base shear value needs to be calculated, which we will be seeing in the next slide. So where these are the tools which we developed, so which will not be more in brief, but you will have a proper code references, and from which table or which clause these formulas or these are considered. So for seismic design, generally we follow Universal Building Code 1997, so which will define your seismic zone. And we have here we have two zones, 2A and 2B. I think in India we have 3 or 4 zones. Sorry, I didn't remember exactly. So there will be soil condition, whether it is a stiff soil, loose soil, or dense or rocky soil. So based on that, you will derive your soil coefficients or the soil bearing capacity you calculate. So based on that, you will arrive certain figures from the code book. So which will be again your response reduction factor or your coefficient of soil. So an importance factor and time period. These are all calculated based on the basic formulas that is available in the code with respect to the building height and with respect to your soil condition. So you will arrive to a base shear value. So where this is my coefficient for the base shear value of a particular project. So I will be multiplying this with my unit weight. So where W is the unit weight, which you will be multiplying with either, if you're considering, as I mentioned, if you are installing a TV in your home, which is at 50th floor of the building. So the weight of the TV is say 100 kg, but the impact when it creates, if the same TV is in the ground floor, the impact the TV creates is lesser because from the height, from the point of seismic activity, it is at a 3 or 4 meter height, if we consider typically a floor height. But when it is 50th floor, the impact is going to be much heavier. So the more the height, the impact is going to be more. So these are the parameters that need to be considered. So as we discussed, wind is one parameter, which is a variable one, which we need to be pre-calculate and do it. And seismic is also a variable one, which we need to pre-calculate and do it. So these are the two. And coming to the temperature, which is the third one. So as I mentioned, we are using multiple materials. So every material has its own temperature coefficients. So the critical ones we always consider, if you take natural stone or metal, which are predominant elements that we are using. So those should accommodate the thermal or temperature variation which comes up. So this is a quick calculations. Again, how do we define these movements is again based on the seasons. So there will be a mean temperature, which will be again calculated based on, last 10, 15 years or will be much more. They'll take there will be a data available in the code books. So you can gather the data and you can choose your building is prone to a maximum of 75 degrees centigrade and a minimum of, 0 degrees centigrade. So which can happen in certain situations in winter, or maybe it's according to the, geography and the climate situations over there. So then you will arrive to a, expansion and contraction of these materials. Like as I mentioned, the stone may expand say 1 millimeter, but the metal may expand 2 millimeters. So we have to consider the worst scenario into consideration because that's what creates an additional stress. So, and we provide an expansion joint where you could see a typical sketch or a drawing. So between the panels, so if you consider top and bottom, which is highlighted in the red box, you can see on my cursor. So there will be a minimum gap that is maintained. So if you could see for this particular project, the expansion happens is, a maximum expansion of 0.8 millimeter and a contraction of, 0.76 millimeter. So where we decided to provide a 2 millimeter gap, keeping a lot of considerations, the workman installation, and there are certain chances that mistakes may happen because you will always not get skilled labor on the site. So keeping all these parameters, the expansion joint we decide. So any given situation, whatever the climatic situations or whatever the stress variations happens in the structure, so these expansion joints will take care of the facade or the building by not implicating any additional stresses on the particular segments. So which will be free to expand and free to contract. So a live example or an example on a large scale, which I can give you is consider you are moving on a bridge. At every 3 or 4 meters, you will heard a tap sound when you are going on a car. So these are nothing but expansion joints which are allowed to keep on the structures. So where these expansion and contractions are taken care. So either it's a bridge or it's a building or it's a facade, or even it can be a small, a drywall partition or your blocker in a home. So when you are not maintaining an expansion joint or when you are not allowing the materials to freely expand, so what happens is that you see cracks or you see the panels falling down from the building. So the quite common thing which we see in most of the residential buildings or in our homes, you will see after constructing maybe 2 or 3 years, you will see a crack in the your partition wall or a blockwork. So the reason is not that the block is weak or it cannot withstand. So when you are not maintaining the joint between your slab and the wall, so such situation, the slab load comes up because, as I mentioned, once the temperature variations comes, material are prone to expand and contract, so which will significantly transfer the loads on the blockwork, as we studied in couple of subjects, either building materials or theory of structures or structural analysis basics. So block walls are freestanding walls and non-load bearing walls. So we should not we should keep enough gap between your floor slab and the height. So the thermal variations or the temperature, the effect due to the temperature loads are taken care. So these are the 3 different loads. Yes, the other 2 loads which we left over is the dead weight and the live load. So live loads are not a predominant aspect that comes in the facade. It will only be a chance of cleaning load, but people are not going to stand on it because the facade is going to be vertically flatted on the building, so which is not a significant parameter to be considered. But however, the dead load is predefined because the dead load itself will have your own panel weight, so which will be precisely chosen. So the dead weight is always a constant weight, so it will be taken care. As you see on the screen, as I mentioned, the dead weight of or you can call it as a density, which significantly derives your weight of each panel. So 2,700 kg per meter cube, or is the dead weight of a panel, or a density of a 1 cubic meter panel that was considered for that particular case what I'm presenting here. So this is how it goes. And coming to the last point of fixing of all these things. So there are a lot of options available in the market, but as I mentioned, as we are ensuring the safety and standards, so there are certain parameters that needs to be considered or approvals that we need to retain when we are choosing a product that needs to be taken care. So here you come up. I mean, these are the tools which we develop for our customized design checks and design submissions, which are not will be available openly in the market. But however, on certain notes, yes, it can be. So sorry, somebody have a question? Yeah, thank you. So you could see that this particular segment what we have designed. So we are going to attach this using multiple anchors. So where you could see the tension loads, which is the representations are here and the table values are here. So N is nothing but the tension load or the pull. You are trying to pull the building away, the panel away from the building, and you are going to test it, which is either tension, axial tension, or a pure tension load, which comes up and which creates, since as I mentioned, the panel is going to be a little away from the building. Why it is away? Because as we discussed earlier, it should be a ventilated facade. So where you have to create a low pressure zone of 100 or 120 millimeters, say 10 to 20 centimeters near to our small scale size. So which creates an eccentricity from the building. So you are installing a panel at certain distance, which is again the concept of cantilever effect. So your load is acting at a distance of X or P, whatever. So which creates an additional movement. So you could see the moment values and shear values, obviously. So the overall idea of this is that, end of the day, whatever the design or whatever the concept, either it's a big building or it's a small panel, the whole cinema lies in your shear force bending moment diagrams. That's it. Okay. So yeah, there's a difference. And also when you're fixing certain items, you could see a piece of metal over here, which we call it as a post-installed anchor bolt or a through bolt. So there are so many options for it. Idea is that generally anchors we need to keep before we put the wet concrete. But as there are a lot of technologies has come up and a lot of things has come up. So to give a simple example, that you want to fix a ceiling fan in your home, and the home is say 5 years or 6 years old. So how do you do it? You drill and the mason comes and puts some anchor and then tight it. So the one which I shows is the same, but it's on a little on higher side where you have 150 years of design life for this, and there are certain things which can give 100 years as well. So these are mostly used in the hard materials like concrete. Again, this is the topic of building materials, which I will just touch and not going to be more in deep. So you have materials like concrete, which is quite hard, which can take much resistance against any loads, and you have blockworks. So you see a lot of innovations and a lot of research papers are also being done. You may see fly ash bricks, hollow bricks, lightweight, air-free, aerated concrete. So you name it, there are so many blocks. So how do we deal with all these materials? And if you could see in certain malls and all structures, you see the blocks are completely eliminated by putting gypsum partition. So there will be a gypsum partition where the inside is completely hollow. So how do we deal with such items and how do we fix it? So we have the similar situation in this project. So the one which I showed you previously is for the concrete, and we have a solid block here which is very weak. So solid block is something that you just hold with two hands, just lift it above the head and just throw it, it breaks into two pieces. So it's that weak. So how do we deal with such materials is again, there is going to be a plug and screw type anchor, which is also I think you would be seeing in a lot of hardware shops, or as I mentioned, you get as a kit when you buy any of the equipments like your WCs or your TV units or whatever the cabinets. So this is also again on a higher note of these are made to withstand a life of the building. So this is the overview of this case study, and there will be some testings and all which will be done on site. So just quickly to come back to our presentation, I would like to show you some more real-time pictures, which we generally do in regular designs and this. So just not to go in more detail, but I would like to just present, how does it looks and the story behind whatever you see in museums or whatever you see in the malls or any of the structures. So before and after pictures are these. So this is a requirement of it's a museum. So they want to install a very large screen as they want to present the history of the country. So this is during construction. How do you see this? So and this is the end a screen is out of our imaginations. The screen is 13 meters in width and 9 meter in height. So which is made of a number of close to 500 or 600 LED panels are assembled together to make. So the whole system is not standing or the not on certain very strong concrete or something. The whole system is standing on the metal profiles or the plotted channel profiles. So the idea is that these are all made pre-engineered, so where you don't need to have a lot of headache or a lot of things on site, which can be reused. So tomorrow, if they want to dismantle it, it's just a matter of 2 or 3 days to dismantle everything and keep it back in shop. So these are some more which looks very minimal, but which makes a significant role or significant engineering is involved in it. So if you go to any hotel, you would see a lot of beautiful bathrooms. So there is a lot of engineering behind it as well. So there is no limit for an engineer to know to present it. Either it should be a mega mall or a superstructure that needs to be constructed. So the same shear force bending moment were involved in every aspect of your daily life. So that's all from my side. So hope you enjoyed my presentation, and there are much more in Facade to discuss. So if any of you would like to get in touch with me, you can scan the QR code which is presented on the screen. So you could get my email and communication details. So it's my pleasure to host all of you. Thank you so much. Now we can go for the question and answer session. So which you are free to ask any of the questions either in chat box or you can ask directly. Thank you. Hello.
Request all participants, please go through the Q&A session. If you have any question, yes, Rajesh, Mr. Rajesh, you have a question on the chat box. Can you please check it?
Yeah. Yeah, Mr. Ganesh Naidu, thank you. What considerations must be made when retrofitting an older building with a newer facade system to enhance performance while preserving historical elements? Yeah, coming to the old structures. Yeah, that's really a nice question. Old structures are little delicate. Before going to do any rectification or any of the modification, it is always very important to do non-destructive testing on a structure. Either there are a lot of things has available in the market or available with industry. Either it can be you have to check the, like if the building is designed for say 100 or 100 more than 100 years, so you have to check whether the strength of the existing concrete or the block or whatever the material they have used is in safe situation to go for a modification. If not, there are also certain things which can be used to do, retrofitting. So where you can strengthen your structure by injecting some epoxies or by adding an additional reinforcement without damaging or without demolishing it. So yeah, which we all regularly deal with such items, which we call it rebar applications or retrofitting kind of applications with epoxy. So which is again a very big subject. So I would like to address this on a personal note, or if I get a privilege to provide another session on that, sure, I'll be happy to take it up. Yeah, and we have other question. What is the maintenance that is required for the clamps depending on the time? Generally, yes, this is also a good question which we didn't consider it. Generally, what happens is, as I mentioned, most of the facade panels are naturally available, and there is a major problem with this naturally available materials is they attract any of the byproducts. Like if you use uh, a metal, so the dangerous part in metals is that it prone to corrosion. As I mentioned, it is exposed to the environment. So the weather is the salt deposits will be there, or the weather is quite harsh. So over a period of time, you see corrosion. Once corrosion starts, what happens is it is going to deteriorate from day one, and nobody can predict when this is going to kill the the fixing, when it is going to fall. So it is very carefully selected in such a way. Any of the facades across the globe, it has to be either an aluminum fixing or it should be a stainless steel. So stainless steel is also there are different grades. So most of the facades are fixed with SS316, which is qualified to use in under the seawater. Also, seawater can directly come in contact; it will not rust. So yeah, it's a costly option, but however, that is one of the main predominant thing that needs to be considered. And coming to the corrosion part, so since as I mentioned, these are naturally available materials, so there is a chance that your facade panel may attract the color of the corrosion, the reddish gray or the reddish or the gray, which will attract the corrosion and which will destroy your panel aesthetic views. Like the beauty of the panel will get destroyed by putting some stains and all. So it is on a very strict note. None of the codes will allow to use the normal metal. It could be a stainless steel where you see our home utensils are made of stainless steel. I mean most of them, or you see also aluminum. So you will rarely see the corrosion, which will never happen until unless it's a defective material. But yes, that is the main consideration for the environmental effect. And when you use stainless steel, that doesn't need to have any additional maintenance. Coming to the next question from Mr. Sai Krishna. Dear sir, what about the modern facade system implementations in old and existing buildings? Is there any impact of lifespan of the building? Will there be due to installation of these new modern systems? Yeah, as I previously answered this question, it's all you can install, you can replace your facades, you can go with the trends in the market. So that doesn't affect your until unless it doesn't affect your strength of the building, and subjected to that, the health of the building, the condition of the building has to be monitored before taking any such decisions. So you can take experts' decisions who are available in the market, who does the structural health monitoring, so they can advise and they can suggest. So we are also a part of it. So we do such jobs here in our day-to-day life. So we can provide a report and we can do a on-site survey, which also, a lot of testings and time-taking process. So, but end of the day, there will be a, it's like a doctor. You went to a doctor with some ill health, so prescription and tablets. So the same way with the structural engineers also. So you get a report, whether advice from them whether to go or you not to go, and they give you a solution as well that if you want to move further proceed, you need to do so and so treatment to your building by strengthening it, and you can move forward. So going to the next question, Mr. Manikanta. So which facade type is most commonly used in skyscrapers? Most of the skyscrapers goes with glass. But there is, it's all again based on the countries. If you see the Middle East, I mean Dubai, Qatar, Oman, or Kuwait, so glass is mostly considered because compared to the stone, the glass thickness that required for facade is much lighter. Stone is always heavier, and also since here the conditions of weather are quite harsh, you will have sandstorms and the temperature goes up to 50-60 degrees centigrade in summer. So where glass can predominantly give more uh, energy saving or the coolness to the building, because there are glass can be altered. It can be laminated, or it can be there is a tint, like you get sunglasses, right? So sunglasses are to protect your eyes from the sun. So similar way for the building. So there are a lot of available options. But when you take coastal countries like India, so where you have not so harsh weathers, but yes, still, but stone or the glass is the major facade material that is being used. Also, you should see the geography of the material availability. So it's all based on the countries. If you go to Western countries, there is no stone and glass. It's purely metal panels, or it can be a composite panels, because the metal and glass cannot withstand that extreme cold weathers. So it depends on the geography. And coming to the next question, Mr. Vishwanath. This is very informative session. Yeah, thank you so much. And yeah, Mr. Sai Krishna again. Is there any quality checks to be done before and after installation of these modern facades? Yes, there is a lot of quality checks are there, and you have to have do this before you are commissioning or handing over your structure or the work what is done. Yes, on a contractor note or a consultant note, yes, these checks are always done on site. So you call it material test documents. I think sometimes, even we do rely on certain universities and colleges to send our materials to test it whether it is complies, like compressive strength of the material is what generally you may check it site. So such situations comes up, and we always rely on third parties to do such testings. And for the testings, if you want to refer certain codes, especially for facades, I'm sorry, I'm really not aware of the IS standards, since from 10 years I have no practice on IS standards. But if you want to go for testings and read about, you can refer to BS 8298, which is purely a facade. You will have a couple of parts, part 1, 2, 3. So I will be dropping that message on chat box. So you can refer to that codes and you can get in detail. Yeah. So moving to the next question. What about toxic materials? Some modern facade materials like certain types of insulation or coating can contain toxic substances. Yeah, I'll answer this question by part, Mr. Sai Krishna. Toxic materials are mostly not allowed in any of the facades. So when it comes to this, these materials are always tested for the safety norms. So as you see, most of your whatever the daily usage stuff you use, you will always have a safety data sheet. So these are all tested for certain safety because these are all the materials that installed by people like us. So you have to take care of their well-being also during handling the materials at site. So these are all taken care. No toxic materials are mostly entertained in construction. But yes, when admixtures are something, like certain times some sprays or flooring materials or coating materials are used. Those are all done on a controlled environment with proper safety precaution. And you will have coverall, which means like from toe to head, the body is completely covered with a mask, and the person might be using some, spray guns or like. So an example is that when you go for a car repair shop, the guy put a mask and spray the paint on the car body. So it's a similar way in construction as well. Fall hazard for the most hazards. Yeah, fall hazard again. Yeah, there is, this is also a different subject. Generally, fall system comes when you have, high-rise buildings to clean those facades. You need some skilled mason as well as skilled equipment, or there are a lot of systems available to clean the facade, which you can refer like threadle system and wire rope system, where people comes on wire rope, which you see in a lot of movies. So similar systems are available. Yeah, this is in well advanced note in the market. So coming to the next question, how should Mr. Ganesh Naidu, how should uncertainties in simulation outcomes to be managed when designing and certifying high performance facades? Sorry, I didn't get your question. How should uncertainties in simulation outcome be managed when designing and yeah, there is always a chance. Yes, when we design something and what is executed on site, yes, it's never gonna be 100% copy paste. So there will be always a challenges because it's construction. Without challenges, none of the construction activity is going to finish. So that's where the role of an engineer comes up. So it's again on the note of practice and note of the tasks that we handle in different cases. So every project is the stone might be the same, the facade might be the same, but the way of fixing and the way of design may change based on your geometry of the building, based on your surrounding considerations. So there comes our codes where they give a lot of safety factors. So as I mentioned, as this session, I'm not going to go in much deep. So generally, the facades are designed to have a safety factor of 7. So if your panel weight or the load that you need to consider is say 1 kg, but where the design is done for 7 kg. So at any given point of time, you are having a 66 times the factor of safety. So such conditions are already defined in the code. Yeah, if beyond that something happens, it's always considered as a natural calamity that nobody can predict, which will always be a scope for development and study. Yeah. So coming to the next question from Mr. Manikanta, what factors need to be considered in this section of facade materials? Yeah, factors are again defined by your loads and your materials. So each material has its own factor of safeties. So if I consider a stone, the stone should have a minimum factor of safety of 7. If it is a steel and concrete, more or less it's the same. The factor of safety varies from 1.5 to 2. Again, it depends on the standards. So if you take British standards or Indian standards, it's on conservative side. Always you will have 1.6 the load factors, which you see in the code books as well, which is on a higher note. Whereas if you take the American codes or the New Zealand codes or Australian codes, they are all mostly fall into one criteria where you will have 1.4 times the actual weight. So these parameters are already mentioned, and also for more information, I'll be dropping the certain standards that is followed for the facade in the chat box. You can refer to those, or you can also drop an email to me. I'll be attending questions on email as well. Yeah, coming to the next question, Mr. Money, external glass to internal glass, how much distance to be maintained? So this is also a question that that depends. If you need more, energy efficient facade, so there are different. Generally, it is 20 to 25 millimeter. But if your requirement of, energy saving, or if your requirement of certifying to a lead certification at higher standards, so the thickness of the glass and the gap between the glasses will keep increasing, and the properties of the glass are altered by adding additional film or tinting, or laminating two glasses together. So there are different technologies that are available. So it's again depends on the requirement of the project, or the requirement of the client, or the owner. Like if you're building a house and you are the owner, so it's your choice. So according to your choice, there will be a lot of options available in the market. So yeah, on a note of price. Yeah, coming to next question from Sai Krishna. What about maintenance and durability of these modern facades? I think maintenance topic we already discussed, that most of the facades are maintenance free. And coming to the durability, it's always the building life. Any facade you take it, the materials are designed to withstand a bare minimum period of 50 years and to a maximum of 100 years. Yeah, certain cases, if it is a importance buildings like hospitals, or fire stations, gas stations, where any natural calamity happens, they should still retain their pollution. They should not get affected, because those who got affected needs access basic facilities like hospital. So these are designed to have more than 120 years life. Yeah. So I hope I addressed all of the questions. If you have any other questions, we still have some more time left. So if you have any more questions, you can put in your chat box, or you can
So,
directly ask.
Mr. Rajesh, can I have a query?
Yeah, please.
Yes. Is there any automated report generating software or detailing software for this particular designs, facade designs, or material testing reports?
It's none of the structural designs are automated, to be honest. But it's always a dependency of multiple tools. Um, Software is just a software. End of the day, you have to take control over the software. And like if I take this live case as an example, we have used Bentley Stat Pro for the basic structural analysis. And also we did our own applications, because you cannot always rely on softwares and proof check whether the software is really giving you an accurate result or not. So certain times, because softwares are predefined and which were developed in different countries according to their local, or limited international standards. So that is why you see most of the time we the industry standards are derived and governed by the independent organizations or the structural engineers. So we also develop our own, either it can be a programmed Python program, or it can be a MATLAB, basic applications we prepare to speed up our work and to ensure that it is according to the local standards. So it is always a multiple software option, and yeah, the whole process you need to be aware, and you can use any of the tools. Like to give a simple example, the Stat does the same job, ETABS does the same job. So it's how command you have on what software, and if you more dive deep into the software, if you know the basic principles, either you can use and you can execute your job. Yeah, I think we do have one more question.
Thank you,
Some
Mr.
modern
Rajesh.
facade.
We have one question on the chat box, Mr. Telkar Sai Krishna has given.
Yeah, some modern facade materials like composite materials can be difficult to recycle. Yes, see, recycle option again, it comes the kind of building that we are adopting for, and there are certain materials which cannot be recycled, like I would say ACP panels, aluminum composite panels, where the byproducts of plastic were used. So, which is also very dangerous when it comes to fire. This is also another topic in facades that, a lot of buildings got fire, and you see recently an incident happened in Kuwait. So there was a fire accident, and thousands of people got affected. I think more than 20 people lost their life. So yeah, recycling is also one of the major topic that has now come in more stringent way, and the fire to be contaminated or with defined compartments. So yeah, this recycling option may come in future in much aggressive way into the standards. But yes, there are a lot of limitations in the codes that what kind of material to be chosen as a building facade. But if it is a naturally available material, as I mentioned, if it is not artificially made, you will always have a challenge for such composite panels. So we have to live with it. Yeah. So any other questions?
Thank you. Thank you, Rajesh. If I ask
Yeah.
for, feedback of this particular session. If anyone was willing to give a oral feedback of this session, kindly join. Feel free to unmute yourself, and you can give the feedback also.
We have one more question. Concrete facade structures, how many types? See, there is no facade of saying concrete. So it's there are different, as I mentioned in my presentation, the facades are not defined on the type of material, but the facades are defined based on the basic requirement of your ventilation. Uh, which again subjected to your aesthetic appearance, how beautiful your building should look like, and what kind of appearance or what kind of material that you want to use. It's always a ventilated facade and a non-ventilated facade. So where a ventilated facades are more inclined and more advanced towards the green building requirements or LEED certification requirements. So the general, the non-ventilated facades, or which we traditionally see, regular buildings, are more related to the old style. But still, there are certain buildings based on again the climatic conditions. If you see Europe region, most of the buildings, most of the residential and commercial buildings are goes with non-ventilated facades because of the extreme weather conditions. But if you see the hot regions like Middle East or Indian subcontinent or Asian side, you will have multiple seasons and multiple balanced seasons. So where you will always see a ventilated facade as booming and upcoming market in the construction industry.
It's excellent presentation.
Yeah, thank you.
It's very because something new for those who have not worked on the site. Okay. Now, but my point here is that whenever we are coming out with the skin, ultimately that load is going to be transferred to the structure only.
Yes.
Whatever the wind pressure that has been created onto the external skin, again it is transferred to the structure only, if I'm not wrong.
Yeah, correct.
Okay. Then in that case, how we can say that the wind load on the structure has been minimized?
No, here, yeah, shall I take over this question?
Please, sir.
Or
Please,
do
thank you, sir.
Yeah. See, coming to the load is never, compromised, or the load never cannot be reduced. But the idea is the impact. So when you are maintaining a, what you call it, the small cavity with a minimum, minimum amount of gap, what happens is the intensity will reduce. The intensity will reduce, and it creates a low pressure zone between your the building and the panel what you are using it. So this is what, but it doesn't subject that the load is getting reduced. It creates a temperature variation, so which will adversely affect your building. So the temperature is getting, the sun rays are coming, it is first hit by this facade element, but it is not directly transferred to your building. So likewise, when the wind is coming and hitting the panel will transfer the load. But ultimately, the wind has some moisture. No, see, ultimately, when you are next to the sea, so how you get heat and cold is it's one form of transmission is through wind only, right? So this is what makes a difference. When you have pressure differences, obviously, when you have extreme weather, cold weather outside, when there is a low pressure in your building cavity, I mean, we are making a layer of low pressure between your panel and the building, so which creates, which maintains your temperature at a significant standard level, normally like what we call it room temperature. So likewise, this zone creates a minimum temperature based on your internal and external conditions. So this will only accommodate or keep up your building at certain it regulates the temperature of the building, but it never regulates your load distribution or the impact of the load. There is no option that we can reduce certain load that is coming naturally onto the building.
That's good. May I ask you one more point for discussion?
Yeah, please.
See, how do we address the fire breakout? When fire breaks out in
Yeah.
any floor, how this precautionary measure or how they are going to address? Now, many places we are seeing that because of the
Mm.
facade, people are troubled because of the suffocation, stampede, and they have not found the fresh air to go out. Fresh air to receive or to smoke to exit out.
Yeah, it's really a very nice question, and you see a lot of cases, and every day it's a news across the world.
Yeah,
If you see, there is
yeah,
a news of
definitely.
fire broke out, and there is a the whole concept starts here is we call it as there are in fire also there are two topics. One is active fire and passive fire. You see, in the videos or in the buildings when you go into the parking lots, you will see some sprinklers or red coated pipes, red color pipes, which will be visible. So they are called active fire system. So what happens is that when the fire comes up, so the smoke will go and hit there will be a sensor over there. So works on the pressure basis. So the sensor will open up and the pipe will sprinkle the water. But unfortunately, this system, what it does is it will try to suppress the fire. That is called it is fire suspension. But there is no thing that fire prevention is, we don't have any system like that. But coming to the facades, the similar principle is applicable. So as somebody asked, sorry, I couldn't name it. So how do we deal with composite panels? So as I mentioned, most of the fire breakouts, what happened in many of the regions are because of these composite panels, which are the active elements that can catch the fire and burn out very fast. So what happens is fire also has a tendency, which we call it as leaf and frog effect. I mean, in simple, when you put some fire on the ground, so the fire goes up, right? So that's the behavior of the fire. So when the fire goes up, what happens is when you have fire in one of the floors, so the fire tendency to go up. So fire needs fuel. So the fuel is your facade, which is a plastic or laminated panel or a composite panel where you have certain wood or certain byproduct of paper or byproduct of plastic, which can easily catch the fire. Once the facade catches the fire and it burns the whole building. But here, taking the whole subject into the scenario, fire is not the problem in a building, to be honest. The problem is the smoke. What happens is every material again has its own emission criteria. So when you have furniture inside, you have carpets, you have sofas and a lot of plastic inside the home, so it creates a lot of smoke. So when smoke travels across the building and smoke travels at a speed of 6 to 8 meter per second, means in a couple of seconds your whole bedroom is going to get filled with a lot of smoke. So when it get the occupants, the people who occupied the building will lose their visibility, and they cannot access the corridor, or they cannot access the building evacuation staircase or such scenarios. What happens is that you will as you mentioned, that stampede will happen and people will go unnoticed. So even it's quite challenging for firefighters. They cannot access the building of this. Yes, obviously, this is also a very dangerous scenario that if you see most of the buildings, see again, cost is involved. That is a secondary aspect where always we see, I need cheap and best. So it should look good, and at the same time, it should not costly more. So there comes this, so-called composite panels, and which are the killers. So I mean, but if you see the market and the standards and organizations, are coming up with a lot of safety standards. People are aware, and governments are taking initiatives to control these by putting regulations. So last 10 years, there is a rapid development. If any of the building to be qualified, even in India, I'm seeing in nowadays that any of the building to be qualified for municipality, how the things work. You go with paper and then use your influence and get it signed. But nowadays these things are getting changed, at least for the priority buildings like malls and this. You must need to have a fire consultant, and he should certify that the building is fire treated. So I mean, this is also a topic I would not extend further more here. If you would like to have one more session on this, either you can drop an email to me, or you can route through our principals from Pace College. So I'll be addressing that. So
It's a good discussion. Okay.
yeah, thank you. Any other questions? Or it is good to interact, it's been many years that we interact with professors, and we always get a lot of insights and guidance from all of you. So we are happy to address such questions. So please your active participation, allow us to, learn something and address this.
Okay, let me share one more point with you.
Yeah,
When
please.
we are going to cover the skin, the reflection is taking place because of the external skin. Now, inside the building, we are trying to maintain the temperature at 27 degrees, let us say. But the other way, we are trying to increase the temperature of the environment, if I'm not wrong. So, is there any such mechanism has been derived or opted, practiced?
No, sir. Can you repeat the question? I lost
When
it
we
in
place
between.
a skin, when we place a skin, definitely the heat waves have been reflected back into the environment.
Yeah.
So inside the room, temperature has been maintained, but because of the reflection back into the environment, the temperature in the open environment will be increased. But at a few degrees, let us say 1 degree. So this is a concept of against a question of sustainability. Inside we are trying to maintain the temperature, but externally we are trying to increase the temperature. So like this, when we go to the mall or office, all outdoor units have been fixed. So outdoor, wherever the outdoor units are there, temperature is high. Where there is indoor unit is there, there's a cool. Okay. Now, consider such okay scenario. Now, do we have any such material where which can absorb the temperature, or say rays, and which will subside? It will not reflect back into the environment. Just with respect to the material behavior. It's not really with respect to the, I mean, say the concept, but is with respect to the material behavior.
Correct. Yeah. See, in this perspective, again, the naturally available materials and artificial man-made materials comes and plays a major significant role. As I mentioned in my presentation, every material has its thermal resistance, and when they prone to either temperature or fire in direct contact. So beyond that limit, yes, it will try to expand, and if it is given the chance that the whatever temperature rise that happens into the environment is something that nobody can avoid, but this will not happen so much in significance with the naturally available materials like your stone, or it can be, in stone also there are different. If you take granite, granite will absorb a lot of heat, and it has a very good property. So even at very high temperatures, it keeps the building very cool. That's why, granite is much famous across the world, and especially India is the largest exporter for these facade panels. But when it comes to the aluminum panels or the metal panels, they are the real killers. They will not only add a lot of weight to the structure, but they increase the temperature of the surroundings. So you'll not that certain facades are now coming up with ventilated facades, where you will have a I mean, people call it as energy efficient building, but end of the day, the facade is maintained by providing certain air conditioning system. So yeah,
So for me, it's a long gap. For me, it's a long gap after leaving Qatar. So I thought of asking you, okay, is there any development or developed materials are available in the society?
Yeah, but now you could see now people are more inclined towards stone cladding, which is if you see the old monuments are all done with stones, so you will not see any aluminum or metals on the building. Very rare, and I don't think so also. But in recent years, the trend has gone to all the beautiful looking facades of this aluminum and metal. But now the trend is coming back again. You see all the iconic structures or the buildings are done with stone, or there is also called GRC, reinforced concrete. So glass reinforced concrete it is, or GRP. So they are also very good heat isolated elements. They absorb a lot of heat. The Statue of Unity, which is installed or which is built in India, is completely done with GRC panels. So it's not a complete solid element. You see the inside the unit, the inside panel. If you see during the construction, it's all hollow. So there is not something solid inside. It's all done with steel structure and a minimum of concrete. And most of the covering, it is just a covering that is done with the skin of GRC. So the practices are changing, and yes, GRC is a very good development that happens in the market. You see a lot of GRC facades, but subjected to that, every facade and every panel has a life and its own maintenance, cleaning. These are all comes in picture.
Especially abroad companies, they prefer to go with the glass facade, like Burj Khalifa. We observe.
Yeah, they are all laminated glasses. Yes, as I mentioned, that there will be a filament between two glasses. So this will act as a heat barrier. Also, it absorbs a lot of heat, and which will be isolated within the panel.
There's a desiccation will take place. Okay, you are absolutely right.
Yeah.
But some point of time there was a discussion that because of having the totally open glasses, when we go for the AC operation, cost of the AC will increase, especially when we don't have the external walls. That was
Yes.
another debatable topic. Sorry, I don't want to continue here. Just out of curiosity with our colleagues, I thought of sharing with you. Just I shared with you, okay?
Yeah, that's the reason. If you the types of facade, there is a double skinned facade. So it is one glass will be out and one glass will be inside. So with it's like a 200 or 300 thickness, and there will be air gap where the air vacuum is created. So in order to reduce the effect of this temperature, but yes, certain you cannot achieve zero U value. So the maximum least possible U value, I mean, again, the UV radiation value, which we term it as U value for the glass facades. So maximum, 0.7 to 0.6 is the maximum best value that you can achieve. So
Probably that is called as a desiccation, if I'm not wrong.
sorry, come again?
Desiccation, if I'm not wrong. I'm not sure.
Yeah.
Generally called as a desiccation.
Yeah.
Okay, fine. That's wonderful. Okay, good. Keep continue.
Yeah.
Thank you, Rajesh. Thank you for your patience.
Yeah, I think we come to the end of the session. Yeah, thank you.
Let me give the final bite of this particular session. Mr. Rajesh is a prestigious alumni, and he's one of my batchmates. I'm very happy and very proud to be announcing him as the resource person today. Thank you, Rajesh. Thank you for your patience and very well. The participants have been very active for this session. I have seen from the last 3 sessions, they have been asking a lot of questions today. Thank you for your patience, and we
Yeah,
expect
thank
more
you.
support from you.
Yeah, thank you, all of you. I would like to thank my college and PACE. It's really pleasure taking me on board, and I would like to extend my thanks and the management and the HODs of civil department and whole staff who is involved in this operation. I think it's been a month that we are coordinating and a lot of discussions, lot of time changes. I really appreciate your support throughout this process. Yeah, I also anticipate to collaborate much more and we can work together. And also, I would like thank all the participants for your time. I think it's already 9 in the night in India. So I really appreciate spending a lot of time here. Thank you so much and thank you all of you.
Thank you, Rajesh. Thank you for your time. Dear participants, we have given the feedback link in the chat box. Kindly update the feedback. And with this, we are closing the session. We'll wait for 5 more minutes to close the feedback link. And kindly fill the feedback link as soon as possible. Thank you, Rajesh. Thank you for joining us. And on behalf of Civil Engineering Department, PACE Institute of Technology and Sciences, all staff members are very thankful to you for joining this session. We'll continue
Thank you.
this relation further. Thank you.
Sure. Thank you. Thank you, all of you. Bye-bye.